A few years ago, I applied for an entry to the Guinness Book of Records. I told them that I could prove I was the man who had carried out the greatest number of S-curve fits. They rejected my application, saying that there was something too specialized for their audience. They were probably afraid that their readers would find S-curve fits too complicated. In fact, they're not. They can be very simple. I have dozens of them in my first book, Predictions, and I will show you here how you can do it using Excel. We'll use as an example the diffusion of the coronavirus in South Korea during the early days. I picked that country because it was more or less a classical diffusion process. We're going to use the logistic equation, which is spelled out right here. It involves three parameters: m, which is the level of the final ceiling of the S-curve, alpha, which is the slope, and T0, which is the midpoint, or otherwise the inflection point of the S-curve. The data for South Korea I took from Johns Hopkins University, and I put them in column C here. And in column A, I have the date, which goes as a label on my graph. In column B, I have sequential numbers from 1 to 27, which is the first 27 days of diffusion. I will use that variable for the time axis because the date has a very big number, and in the exponential, it may cause us troubles. So we will type the equation on this cell here, equals the ceiling divided by 1 plus exponential minus the slope times the time variable minus the inflection point. And then I'll go and put dollars in front of the numbers so that when I drag it down, it doesn't change. These are the constants, so those should not change. So I can drag this down now all the way to the end, in fact, even farther, because we're going to make a forecast. Our S-curve is this red line here, which doesn't look at all like an S-curve because my parameters have arbitrary values. We should improve on those because they will serve as the starting points for the search of the final values. So clearly, the ceiling cannot be 10. It's already 3,500 today. So it should be more closer to 10,000 is a more reasonable number. The slope is generally a small number. So let's put 0.5 for the slope. And the midpoint, a better value for the S-curve's midpoint, the inflection point, could be closer to the end of February. So end of February here, it corresponds to our X variable, our time equivalent of 15. So if I type 15 here, we'll see that we get an S-curve that approaches the data pattern. Now, to get our fit, to make Excel give us the best values, we have to enter here the difference between the number of cases and the S-curve square. This difference squared will multiply it all the way to the end of the data. And we'll enter here the sum of all these differences squared, because this effectively is something very close to what they call a chi-square. So minimizing this will make those curves, the data curve and the S-curve, identical. Now, this will be minimized with the help of the solver. The solver is a function of the Excel. If you go to the Data tab, you will find it on the right here. together with data analysis. If you don't see it here, you have to introduce it, to install it. It's easy to install the solver if you don't see it. You just go to the Office button, choose Excel options, then add-ins, and then the solver add-in. That's all. Now, once you have solver installed, the data tab will give the solver will open a window asking you what is to be minimized or maximized. On this cell here, we will enter E6, which is the sum of our differences squared. It will mark minimize here, and then for the cells to be varied, we'll pick those three. That is M, A, and alpha, and T0. In other words, we're telling solver to minimize this red cell, which is equivalent to the chi-square, by varying those three parameters. You type solver, and you see that you get a very good agreement with the S-curve and the data points. And that's it. You have a forecast, you have a description of the early day of the diffusion process of COVID-19 in South Korea, and a description of the time and a projection forward, making a forecast. Now, in follow-up videos, I will tell you how to estimate the uncertainties on these forecasts, particularly on the final number. Here it says it should be close to 8,000. What's the uncertainty of that? Another video will be how to avoid a bias that S-curve fitting generally produces towards lower ceilings. And a fourth video will tell you how to choose whether to fit cumulative data or daily data or data per unit of time. But all these are for later. Bye for now.